Welcome to 7.4 multiple angles formula. So each of these are going to be special double angles. We have a whole bunch of different half angle formulas. And you get to pick and choose which one of these you want to use when it comes to the half angle formulas. And then in the double angle formulas, there's three different cosine double angle formulas that you could choose from. So let's get started. On the first six here, I went ahead and put the formulas that we will be using. We want the sine of 2u, the cosine of 2u, and the tangent for 2u for all the given values here. So in the first quadrant, the cosine of theta is 3/5. So if we look at that, the cosine is the adjacent leg over hypotenuse. So that means y is 4, 3, 4, 5 triangle. So now we have the sine of 2u equals 2 times the sine of u, all right? So the sine of u is, and u is the angle there, 4/5. So 4/5, and the cosine is 3/5, which we already had that. So that gives us 12 times 2, which is 24/25. That would be the double angle formula, okay, for the sine of 2u. Now, the cosine of 2u is equal to the cosine squared. Again, cosine is 3/5. We're going to square that. Minus the sine squared. The sine squared is 4/5, and we got to square it. So 9/25 minus 16/25 would be negative 7/25. Okay? And then tangent of 2u. So we have 2 times the tangent is y over x, so that's 4/3. And this is 1 minus 4/3 squared. So 1 minus 16/9, so that's 9/90, the common denominator. So 9 minus 16 is negative 7/9. Okay, and on top we have positive 8/3. So that's 8/3 times the reciprocal, and we reduce, and that's going to be 24/7. So look, I put the answers here for you, and that matches what we have. All right, so let's go ahead and do the next one. All right, so we have to write a little bit smaller here. Okay, so to save space, we just added a few more slides here. So let's move on to number 2. Okay, so first of all, you have cotangent of 4/3, so we need to draw this, and it tells us we're in the third quadrant here, okay? So cotangent is x over y, and for it to be positive, that means both of these are negative in the third quadrant. And again, this is a 3, 4, 5 triangle. So now the sine of 2u is equal to 2 times the sine of u. Sine is, again, this is u here. U is opposite leg over hypotenuse, and the cosine is adjacent leg over hypotenuse. So that's positive 12, that's 24/25. All right, so that's the sine of 2u. Cosine of 2u is the cosine squared, so we have everything right here. Cosine squared would be negative 4/5 squared. Sine squared is negative 3/5 squared. And we have positive 16/25 minus a positive 9/25. When you square a negative, it becomes positive. So this is 7/25. And the tangent of 2u is 2 times the tangent. Tangent is opposite over adjacent, or negative 3/-4, which is 3/4. All over 1 minus the 3/4 squared. All right, so that gives us 6/4. And this will be 9/16. So 16/16 minus 9/16 is 7/16. This is 3/2 reduced. So we have the top times the reciprocal of the bottom. We can reduce diagonally, so that's 24/27. And we see our answers are correct there. So now we're looking at the secant of theta, which is the same thing as cosine of theta being the reciprocal, negative 12/13. So here we're in the second quadrant. So we're looking at cosine is negative 12, and the hypotenuse is 13. So this is a 5, 12, 13 triangle. And so the only thing negative would be the x value. So now let's do it. 2u, sine of 2u is 2 times the sine of u. Sine of u is 5/13. Cosine is negative 12/13. So we have 2 times 5 is 10. 10 times negative 12 is negative 120. 13 times 13 is 169. Okay. And then cosine of 2u is cosine squared, which is negative 12/13 squared, minus the sine squared, 5/13 squared. So 144 minus 25 all over 169. 119 over 169. And then tangent of 2u equals 2 times y over x, which is 5 over negative 12, and 1 minus negative 5/12 squared. So negative 10/12, and this is going to be 25 over 144. So 144 over 144 is 1, minus 25 is 119. 119 over 144. Okay, so keep, change, flip. Negative 10/12 times 144 over 119 is 12, or negative 120 over 119. And those are the answers they have in the book. Number 4, sine of negative 12/13. We are in the fourth quadrant. So we're looking at the y value being negative 12, and the hypotenuse is positive. So again, a 5, 12, 13. So 2 sine of u. So we need 2, and the sine of theta we already have is negative 12/13. Cosine is 5/13. What do we have? Negative 24 times 5 is negative 120 over 169. Okay, and cosine squared is going to be 5/13 squared minus the sine squared, negative 12/13 squared. So 25 minus 144 over 169 is going to be negative 119 over 169. The tangent of 2u is 2 times the tangent. Tangent is y over x, negative 12 over 5, all over 1 minus negative 12/5 squared. So what do we have here? We got negative 24 over 5. The denominator is 25, so the 1 becomes 25 over 25. 25 minus 144 is going to be negative 119 over 25. So negative 24 over 5 times the reciprocal, 25 over negative 119. So negative times negative is positive. 24 times 5 is 120 over 119. So those are the answers that we have down at the bottom. Number 5, if alpha is 3 and alpha is acute, find the exact value of the sine of 2 alpha. All right, so we have a triangle where this is alpha. Tangent is y over x, so this is 3 over 1. And we know that it's acute because, first of all, if it's in a right triangle, both of these angles are acute. Okay, so 3 over 1, so what do we have here? So c squared is equal to a squared plus b squared, so 1 plus 9 is 10, b to the square root of 10 for what we're doing on this. So the sine of alpha here is 3 over square root of 10. Cosine is 1 over the square root of 10. So now this is 6 over the square root of 100, or 6 over 10, which is 3/5. Now the cosine squared is 1 over the square root of 10 squared minus 3 over the square root of 10 squared. So that's 1/10 minus 9/10, or negative 8/10, and reduced by 2, you get negative 4/5. Okay. And tangent, 2 times the tangent. Tangent is already 3. Okay. And 1 minus 3 squared. So that's 6 over 1 minus 9 is negative 8. Divided by 2, you get 3 over 4. So negative 3/4. So I left those answers off. Apologize. But 3/5 was the first one. So we're doing them right. Next one. Same thing here. Cotangent is x over y. And that's 2 over 1. It's acute. So again, we're just going to do it in the first quadrant, or just draw a right triangle, okay? So alpha is 2 and y is 1. So what is c? So 4 plus 1 is 5. This would be square root of 5. So now 2 times the sine. The sine of alpha is 1 over the square root of 5. Cosine is 2 over the square root of 5. And that's 4 over 5. And I see now that we were only supposed to find the cosine of 2 alpha. That's why there's only one value down here. Okay. All right, so all we need to do is this. So cosine squared is 2 over the square root of 5. And the sine squared is 1 over the square root of 5. So that's 4/5 minus 1/5, which is 3/5. And that's what's down there. All right, let's move on. Okay, now we're doing all of these again for the given conditions. We're in the first quadrant. Secant is the same thing as cosine, except it's the reciprocal. So we have, just draw a triangle in the first quadrant. And cosine is x over hypotenuse. So this is a 3, 4, 5 triangle. So now we just do all of these again. Now these are going to be the half angle formulas, which I've put here. So we get plus or minus the square root 1 minus the cosine of v. So this is v here. Cosine is 4/5, and that's over 2. So 1 is the same thing as 5 over 5. So this will be plus or minus the square root of 1/5 over 2, which is 1/5 times the reciprocal of 2, which is the square root of 1/10. Again, this is all plus or minus, which is going to be, if we rationalize this, we're going to get the square root of 10 over 10. And that's what that is, so they didn't say anything about it. Now it's positive because we are in the first quadrant. So notice they don't have any positive or negative signs on here. So this is a positive 1 over square root of 10 because we're in the first quadrant. This is important to note as we go on. All right, we got to do the cosine, half angle of cosine. Cosine's positive in the first quadrant, and the half angle of that is still going to be positive. So we have 1 plus, again, the cosine, 4/5 over 2. So 5 over 5, that's 9/5 over 2, which is 9/5 times 1/2, which is going to be square root of 9 over 10, which is 3 over the square root of 10. We'll leave it like this since they're leaving it like that. And then also, tangent is positive in the first quadrant, and the half angle of it is also positive. So 1 minus the cosine over the sine, 3/5. So 5 over 5 again, that gives us 1/5 over 3/5, which is 1/5 times 5/3, which is 1/3. And that's the final answer. All right, same thing here. Whoops. Let's move this up. And we'll move this one down. Okay, so now we do the half angle of cosecant. Cosecant is the same as the sine, except it's the reciprocal. You are in the fourth quadrant. So I'm going to draw this in the fourth quadrant. Okay. And sine is y over the hypotenuse. And again, this is a 3, 4, 5. And this is mostly about the negatives. That's why we're doing this, and learning to use your formulas. So in the fourth quadrant, sine is negative. Now, is it negative, the half angle of that going to be negative? Well, we'll have to find out. Okay? So we have the square root of 1 minus the cosine. Cosine is 4/5 over 2. So 5/5 minus 4/5, all over 2. This is under the radical. So that's 1/5 over 2, which is 1/5 times 1/2, which is 1 over the square root of 10. Now, is it positive or negative? Well, I want to show you something here real quickly. Any value over here, if you divide it by 2, so we got 300. 300 divided by 2 is 150. So y is positive at 150. If we go down to 280, half of that's 140. Okay, what about 340? Half of that is 170. So the half angles of these are still going to be in the second quadrant where y is positive. So just to have you think about what it is that we're doing. All right, so the half angles are going to be positive. But here's the rub of all of that. It is the normal sine value that you're supposed to give it. You are in the fourth quadrant, so that's why this is negative. It doesn't matter if your half angle is actually positive or negative. It matters where the original trig function is talking about. Okay, so let's look at the cosine. Think of it this way. If I say I want to know the cosine of 300 degrees. Okay, so let's just look at this again. 300 degrees is right here. All right, the cosine, let's do sine, just to make it so it's obvious what we're doing here. The sine is negative square root of 3 over 2 at 300 degrees. All right, well, how do we figure that out? Let's say we didn't know what 300 was, but we could figure out what the sine of 600 over 2 is. So 600 over 2 is the 300, and here's where the half angle formula comes into play. All right, so what this is saying when we're using half angle formulas is we're doubling something. We're not taking half of it. We're doubling the original value to use these half angles to figure out what the value is. Okay, so because we are in the fourth quadrant, that's the original angle. So the sine is always negative in the original angle. So they double it and then say divided by 2. And what happens is this becomes the value that is in the function. So as we progress, you'll see how this works. It's okay if you don't understand that yet. Don't worry, we'll get there. So let's just do this now. We are in the fourth quadrant. The cosine is positive in the fourth quadrant. So let's just figure everything else out here. 1 plus the cosine. Cosine is going to be 4/5, and it's over 2. So again, 5 over 5, that's going to be 9/5 over 2, which is 9/5 times 1/2, which is 9 over 10, which is 3 over the square root of 10. And cosine is positive in the fourth quadrant. Tangent is negative in the fourth quadrant. So notice we have a negative in our answer. So 1 minus the cosine, 4/5, all over the sine, negative 3/5. Again, 5 over 5, that's going to be 1/5 over negative 3/5, which is negative 1/3. All right, here we go. Oops. I don't know why these are all in a weird place. Okay, so again, sine. Where are we? We are in the the second quadrant. So sine is positive in the second quadrant. 12/13. 12 and 13. Again, 5, 12, 13. But x is negative in the third quadrant. So what do we have? The sine, again, this is going to be positive. 1 minus the cosine, which is negative 5/13 all over 2. So this will be 13 over 13 to get a common denominator. Change. So that is going to be 18 over 13 over 2, which is 18/13 times 1/2, or square root of 9/13, or 3 over the square root of 13. And it's positive. Okay, second, cosine is negative in the second quadrant. So we have the square root of 1 plus the cosine, negative 5/13 over 2. So again, 13 over 13. That'd be 8/13 over 2, which is 8/13 times 1/2, or 4/13, or 2 over the square root of 13. And this should be negative because you are in the second quadrant. The cosine is negative in the second quadrant. I'm not sure what is happening with this answer key here, but that should be negative. All right, so now the tangent, excuse me, of v. So here we have v again. So it's 1 minus the cosine is negative 5/13, all over the sine of 12/13. Okay, so now we get, let's see here, 13/13 for a common denominator, change, that's going to be 18/13, over 12/13, the 13's reduce out, 18/12 reduces to, by 6, that gives us 3/2. All right, so you're not doing plus or minus here because the tangent is equal to whatever you figure out on there. So it's only plus or minus when you're dealing with the square roots. All right, so let's go ahead and set everything back up again. All right, the tangent is, we are in the fourth quadrant, okay? So fourth quadrant, and this is theta. Tangent is y over x. It's negative, so y is negative and x is positive. And this is 13, 5, 12, 13 triangle. All right, so now sine of v over 2 is equal to the square root of 1 minus the cosine, which is 12/13, and over 2. So again, get a common denominator. So that's 1/13 over 2, or the square root of 1/13 times 1/2, which is 1 over the square root of 26. Okay, the cosine here is going to be the square root of 1 plus the cosine of v, which is 12/13. Again, 13/13, common denominator, that's 25/13 times 1/2. So the square root of 25 is 5, and on the bottom we have 20, square root of 26. And the tangent is 1 minus the cosine, 12/13, all over the sine of theta, so that is going to be negative 5/13. Okay, so what do we really have here? This 13/13 again, so that's 1/13 all over negative 5/13, which gives us negative 1/5. Tangent of theta is 1, so we're at 45 degrees for it to be 1. For it to be positive 1, it could be in the third quadrant, which is what this is really saying. So now we have our answers here, and let's go ahead and figure these out. So we have the square root of 1 minus the cosine. So we are in at this position here, and negative square root of 2/2, square root of 2/2, negative again. So cosine is negative square root of 2/2, all over 2. So change, and 2/2. So we get 2 plus square root of 2 all over 2, all over 2. Okay, multiplied by the reciprocal. So this is 2 plus square root of 2/2 times 1/2, or 2 plus square root of 2/4. And we take the square root of 4, so 2 plus square root of 2 all over 2. And again, that's under 1 radical there. All right, now, and that should be negative because you are in the third quadrant. The cosine, let me see here, we have 1 plus the cosine again, which is square root of 2/2, all over 2. So we're doing all the exact same things again, so we're going to drop down to the square root of 2 plus the square root of 2 all over 2. And this will be, except it's negative square root of 2. So really it's 2 minus the square root of 2 over 2 times 1/2. Again, it'll be 2 minus the square root of 2 over 4, which is 2 minus the square root of 2 over 2, but the radical is still on the top. And then we go to the tangent, 1 minus negative square root of 2 over 2. And the sine function is going to be negative square root of 2 over 2. Change. So overall, it's going to be negative. See what we have here. 2 over 2, common denominator. So 2 plus the square root of 2 over 2 times the reciprocal, negative 2 over the square root of 2. All right, so that cancels out, leaving a negative and negative, and we have 2 plus square root of 2 all over the square root of 2, multiplied by the square root of 2 to remove it. 2 in the denominator. And you have 2 square root of 2 plus 2. All right, so what they have down here is the 2's will reduce because it can go to both of them. So that's just negative square root of 2. It should be minus 1 because you got to distribute them negative through. And that's what we have. All right, oops. So the sine, let's see, we're in the third quadrant. Secant goes with cosine, so the cosine is negative 1/4. Third quadrant, negative 1 over positive 4 there. And so now we have 16 minus 1 is 15. This is the square root of 15 here, negative. So now we have the square root of 1 minus the cosine. Cosine is negative 1/4 over 2. So 1 plus 1/4 is 5/4 all over 2. So 5/4 times 1/2, or the square root of 5 over 8. And that's the square root of 5 over 2 square root of 2. So multiply by the square root of 2, and we get square root of 10 all over 4. Cosine, it's 1 plus the cosine. Cosine again is negative 1/4 all over 2. So 1 minus 1/4 is 3/4 all over 2, which is the square root of 3 over 4 times 1/2. And that is the square root of 3 over 8, square root of 8, which is 2 square root of 2. Multiplied by the rationalization, square root of 6 all over 4. Okay, and third quadrant cosine is negative. Now, tangent, 1 minus the cosine, which is negative 1 over 4, all over the sine, which is negative square root of 5 all over 4. Common denominator, so change, that's 5/4 all over the negative square root of 5 over 4. So 5 over 4 times the reciprocal, 4 over the square root of 5. You get 5 over the square root of 5, and then we rationalize, and we get 5 square root of 5 over 5, or square root of, so this is supposed to be 15, not 5. 15, 15, 15, 15, 15. That changes all of that. So this is 5 square root of 15 all over 15. And that's negative, and the 5 and the 15 reduced to 3 there. So this is negative square root of 15 over 3. All right, cosine of b is positive, so x is positive. B is in the fourth quadrant. So if we're in the fourth quadrant, cosine is positive, adjacent over hypotenuse. Pythagorean theorem gives us 40, Pythagorean triple. Find the exact value of the tangent. So all we need here is the tangent part, so I'm going to erase all of that and move this up here. So now the tangent is 1 minus the cosine. The cosine is 9/41. The sine is 40 over 41. Get a common denominator. You get 41 minus 9 is 32. Times the reciprocal of the bottom, 41 over 40. So now you have 32 over 40, which reduces by 8 to give me 4/5. And that should be our answer. Now, it's negative because you're in the fourth quadrant, and the y here, negative 40 should be negative, which makes this negative 4/5. Okay, cosine, let's do cosine of theta is equal to negative 7 over 25. And we're finding the tangent again, so let's erase this other stuff. So we got to find the tangent. So again, 1 minus the cosine all over the sine. So we got to find the sine. So your sine, let's see, cosine, secant was cosine, that was negative, x is negative. And it wants all the possible values for the tangent here. So let's just draw in the second quadrant here, -7 and 25. This is 24. Okay, it also could have been down here. Okay, so two possibilities here. So one where the sign is positive, 24 over 25. So that is going to be change, 25 over 25 is 32 over 25 over 24 over 25. And multiply by reciprocal, that becomes 32 over 24 reduced by 8, and we get 4/3. And if you have the negative down there, then this just makes it a possible negative as well. So plus or minus 4/3. Half angle formulas to find the exact values. So we have our half angle formulas up there again. So let's see here. Half angle formulas find the exact values of the cosine of 67 degrees 30 minutes. Okay, so if we double this, all right, we're going to use the cosine formula for this one. We double it, and we're going to get the cosine. 67 times 2 is going to be 134, but 30 times 2 gives me up another degree, gives me to 60 minutes, which is another degree, so that's 135. So 135 divided by 2 is the exact same thing as the 67 degrees 30 minutes. So now what do? It's plus or minus, and now it's 1 plus the cosine. Well, the cosine is the 135. See, V is in the top position, and V is in that position there. So the cosine at 135 divided by 2. So the cosine of 135 is negative square root of 2 over 2. All right, so now, get a common denominator. So 2 minus square root of 2 over 2 times the reciprocal, and we get 2 minus the square root of 2, square root of that, all over 2. All right, so those are the exact values. Now, we can do the sine, so we use the sine formula here. Again, double this. So we get the sine of 30 over 2, and that equals the 15. So we're in the first quadrant with this, so it's going to be positive here. All right, same thing with the cosine. Cosine was first quadrant. So now you have the square root of 1 minus the cosine of 30 all over 2. The cosine of 30 degrees is the square root of 3 over 2 all over 2. All right, so again, 2 over 2, we get 2 minus the square root of 3 over 2 times the reciprocal. So that's just 2 minus the square root of 3 all over 2. And now the tangent is going to be, and again, these are in opposite order here. Tangent's 1 minus the cosine of V. All right, so 3 pi over 8. And if we double it, it will be 6 pi over 8. So it's the tangent of 6 pi over 8 over 2. Okay, so we divide that by 2, we're going to get 3 pi over 8 again. Okay, so this is 1 minus the cosine of 6 pi over 8 all over the sine. Okay, so the sine at 3 pi over 4 is going to be positive square root 2 over 2. Okay, and this is 3 pi over 4. So it's 1 minus negative square root 2 over 2 all over square root 2 over 2. Or you get 2, change, plus square root of 2 over 2 times 2 over the square root of 2. So now it's 2 plus square root of 2 all over the square root of 2. We got to multiply by the square root of 2. We get 2 in the denominator. We get 2 square root of 2 plus 2. And all the 2's reduce to the square root of 2 plus 1. Okay. Number 16. So now we're just finding the cosine on A and the sine on B and the tangent on C. So the cosine 165, what we do is we double that. So that would be 330 degrees over 2. So the cosine of 330 degrees over 2, that is the same thing as 165 degrees. All right, so now we have the half angle formula for the cosine. So we're going to use that. That equals, I'll write to the left here. Okay, so that is plus or minus. Now, how you need the plus or minus is this. What is the value of cosine at 165 degrees? The value of the cosine at 165 degrees is in the second quadrant, so the cosine is negative. So we know right off the bat it's going to be negative. Now it's 1 plus the cosine of the top number that you came up with. So 330 all over 2. All right, so what is the cosine at 330 degrees? Well, 330 degrees, here's 270 plus 60 more. So that's going to be a 30-degree reference, if you didn't know. The cosine is the square root of 3 over 2. So what we have is negative square root of 1 plus positive square root of 3 over 2 all over 2. And then you just simplify. So let's see here. On the top, we have 2 over 2, which is 1, plus the square root of 3 over 2. So 2 plus the square root of 3 all over 2. And that is all over 2. Okay, so you're going to take the top times the reciprocal of the bottom. And that gives you negative square root of 2 plus the square root of 3 all over 4. Okay, so really negative 2 plus square root of 3 all over 2. And that's what we have in the first spot here. All right, now we're going to do sine. So we need to double this. All right, so the first thing we need to do is understand that that is a half of an angle. And when we double it, we get a full angle. All right, so let's do this here. What is it, positive or negative? 157 degrees is in the second quadrant. The sign is positive. So we already know we're going to use the positive value. Now, what is double 157 and a half? So that'd be 315. So we want the sine of 315 degrees over 2. Okay, so that is equal to a positive 1 minus the cosine, again, of the top number, 315, all over 2. So the cosine at 315 degrees, well, where is that? 315 degrees, remember, there's 270 and 45 more. So it's a 45-degree reference, and the cosine is positive in that respect. So 1 minus square root of 2 over 2, all over 2. And now we just simplify. 2 over 2 minus the square root of 2 over 2, all over 2. So you're going to multiply the top by the reciprocal of the bottom, and we're going to get the square root of 2 minus the square root of 2 all over 4. And that is the square root of 2, let's do that again, square root of 2 minus the square root of 2 all over 2, and it's positive. And then tangent doesn't have a square root, so we don't need to worry about positive or negative, but we do need to double this. If we multiply that by 2, we get 2 pi over 8, which is pi over 4. So the tangent of pi over 4 is going to be the same thing, over 2. That's the same thing as pi over 8. So that equals 1 minus the cosine of the top, pi over 4, all over the sine of the top, pi over 4. All right, so the cosine of pi over 4 is positive square root of 2 over 2. The sine of pi over 4 is positive square root of 2 over 2. Get a common denominator. So on the top, we get 2 minus the square root of 2 all over 2. And we're going to multiply that by the reciprocal of the bottom, 2 over the square root of 2. So we have 2 minus the square root of 2 over the square root of 2, and we have to rationalize this. So it gives us 2 square root of 2 minus 2 all over 2. And the 2 will reduce in both those terms, so that's square root of 2 minus 1. All right, now we're verifying the identity. Just change the left side to make it look like the right side, or the right side to look like the left side. So we might be able to use a summation here of 5 theta plus 5 theta, and that's sine of 5 theta, cosine of 5 theta, plus sine of 5 theta, cosine of 5 theta. All right, so where is 5 theta? It's an odd value, but it doesn't really matter because what do you have here? You have 1 plus another 1 of the exact same thing. So this is 2 sine of 5 theta, cosine of 5 theta. You have 2 of them, and that is exactly what the right side is. Okay, on number 18, we can go ahead and simplify that the same way we did number 17 as the cosine of 3x plus 3x, and that's the cosine 3x minus sine 3x sine 3x. Well, there you go. Cosine times cosine is the cosine squared 3x minus, and the sine 3x times sine 3x is sine squared of 3x. Check. So the left side of number 19 looks like half angle formulas, and that might be ugly, but let's try it. 4 times the square root of 1 minus. So before I finish that thought, I had the thought of putting all these on this page for you, and understand that you have a lot of different things going on here. You're just trying to prove really the double angle formulas on the left side here, and how they match up with the identities and the formulas on the right side, or vice versa. So we're going to go ahead and show you all these things, and let me scoot this down a little bit here, and put these into play and show you kind of which way you should go. And sometimes it's easier to go another way. So we're using the sine here, which is the minus, you're going to do minus the cosine of x. Remember, you do it of the top value, the x over 2 there. So this is the sine identity, okay? And the same thing as a half angle, or actually we're using half angle formula is what we're using. All over 2, all right? And then the cosine of your half angle formula is going to be 1 plus the cosine of the top over 2. All right, so when you multiply these together, let me change the color here. You're taking the inside of your radicals, multiplying them together. Notice this is the difference of squares. So inside this radical, we have 1 minus the cosine squared of x. And underneath, when you multiply the 2 times the 2, you get 4. And we have a 4 on the outside. Okay, so now the square root of 4 on the bottom, okay, is going to be 2. And 1 minus cosine squared is sine squared. And the 4 and the 2 reduce to just 2 over 1. And the square root of sine squared is the sine of x. Check. So good job. All right, so you have to pick and choose what you're looking at. The 2 sine of x on number 19 on the right side is just a normal equation form, an expression. There's no double angle in that. Notice that you have at the bottom here, that's a double angle when it has the 2 times something. So you wouldn't want to use a double angle for that. So we're stuck with that. That doesn't do anything for us. So we had to address the left side. So let's look at number 20. Same thing on number 20. We really can't do anything on the right side other than you might be able to notice if we factored out a 4, and I'm just going to do this as we're talking about it. You get 1 minus sine squared of alpha, which is cosine squared of alpha. All right, so that's what all 3 of these could be answers on the right side. So now we're going to look at the left side because I can't really do anything else. Those are 3 possibilities on the right side. On the left side, sine squared of 2 alpha, that's a double angle, okay, but it's sine squared. All right, so if we look at that, that could be 1 minus cosine squared of 2 alpha. And again, it is squared. All right, and then underneath you get sine squared of alpha. So the square just means you have 2 of them. All right, so here we go. So the sine of 2 alpha times the sine, of 2 alpha. That's the top, all over the sine squared of alpha. I'm going to leave the sine squared of alpha off as we're doing the top here. Okay, so what is the double angle formula? So now we look at our double angle, and that is 2 sine of u cosine of u, and then again, you have 2 sine of u, so 2 sine of u cosine of u. Well, that's 4, right? This is all multiplication between them, so you can rearrange multiplication. 4 sine squared of u cosine squared of u, I'm sorry, alpha. I'm using the u from the formula. Okay, and that's all over your sine squared of alpha, which reduces out, and you have 4 cosine squared of alpha. Check. So I did both sides, and you can do both sides. At this point, I would have gone and said the 1 minus sine squared, and then distributed the 4 through. So you could have done it all from one side. Okay, so now let's do number 21. Again, I'm going to drag the formulas over here. Okay, so let's simplify the left side here. It's a half angle identity, or I guess it'd be a formula here. But you have 2 of them because you have it squared. And since it's squared, notice what happens when you take the half angle formula and you square it. When you square a square root, it goes away, which gives you the half angle identity, except instead of cosine of 2u, it's just cosine of v. All right, so in this case, x for what we're doing. So really what we have is 1 minus the cosine of x over 2. Now, that's on the left side. How in the world are we going to get 1 plus cosine of x in here? And again, this is one of those things you need to try to pull together as a tool to do. If I multiply the bottom by 1 plus cosine of x, I get what I need in the bottom. But what I do to the bottom, I have to do to the top. And notice that is the difference of squares, which would become, on the bottom we have 2, 1 plus cosine of x. On the top we get 1 minus the cosine squared of x, which is your sine squared of x. All right, so you need to understand you always try to do your basics, okay? And if the basics don't work, then you work on the formulas that you've been given. And if the formulas don't seem to be getting you anywhere, which they really don't, they get you started, then you have to do other things, like multiplying the top and bottom by something, and then, or maybe squaring the top and the bottom. Maybe introducing a difference of squares to make it work. So there's lots of things to do, and it's just not that cut and dry what you should do each time. All right, so the more of these you practice, the better you get at them. So on number 22, it's the same type of thing. Basically, the same problems go together. So the cosine squared of x minus 2, x over 2. So if you look at this down here, if we square it, the radical goes away, and it leaves us with 1 plus the cosine of x all over 2. And again, we would multiply by 1 minus the cosine of x on the bottom and on the top, which is your difference of squares. So it's 1 minus the cosine squared again, all over what you wanted on the bottom. And so that gives us the sine squared on the top, and the 2 times 1 minus cosine of x on the bottom. So check. So we just got to keep trying, putting this stuff in different forms and learning to do different things. Again, I'm going to stick with the left side at the moment. And if I do that, it's going to give me some crazy looking things when I square, when I square this, okay? So sine plus cosine times sine plus cosine, all right? So let's see what it gives us here. That's sine squared plus sine cosine plus sine cosine plus cosine squared. And we see we have cosine squared and cosine squared, that's 1. So we have 1 plus, and again, this will be 1 sine cosine plus 1 sine cosine. That gives us 2 sine cosine, which is this right here. So it's 1 plus sine of 2, let's see, these are t's, 2t. Check, done. Number 24. So you want to have these formulas right there in front of you. And the more you look at them, the more you'll recognize them as you're doing other things. Okay, cosecant of 2u is the same thing as 1 over the sine of 2u. Okay, so we're just going to write it like this, sine of 2u. And that's just the same thing, sine of 2u, again, is going to be 2 sine u cosine u. Oops. And the sine of u is 1 over the cosecant of u. And the cosine is 1 over the secant of u. Okay. Now we have the 1/2 right here. And it's still going to be 1 over these inverses here. So basically top times the reciprocal of the bottom is going to give you cosecant of u, secant of u. Okay, the reciprocal identity is what I meant to say. So check that one's done. Okay, so at first glance, sine of 3u is not very complex, but it really is. You could do the right side if you wanted to, but at the moment I'm not really sure what to do with the 3 minus the 4 sine squared of u. So I'm going to attack this from the left side again and just make this an addition formula of sine. So that's sine of u, cosine of 2u, plus sine of 2u, cosine of u. Okay, so now let's look at the cosine of 2u. Again, I want to try to get rid of cosine here. So I'm going to look at this down here where I can change the double angle to a sine. So this is going to be sine of u times 1 minus 2 sine squared of u. And sine of 2u again is 2 sine u cosine u, and times cosine u. And this is the same thing as sine squared, 1 minus sine squared, because cosine times cosine is cosine squared. Okay, so now let me rewrite it so we can see it. The sine of u times 1 minus 2 sine squared of u plus 2 sine of u times 1 minus sine squared of u. So let's distribute and see what we have, and then we can probably factor. We need to put things in different order. These two are not the same. This is 1 minus 2 sine squared of u, and that's 1 minus 1 sine squared of u. Okay, so if we distribute, I don't know if this is going to be the best way to do this. Sine cubed of u plus 2 sine of u. We're distributing here too. Minus 2 sine cubed of u. All right, so at this point, let's put like terms together here. We have a minus 2 sine cubed u and a minus 2 sine cubed of u, so that's minus 4 sine cubed of u, which looks very close, but not quite. And then we have a plus 2 sine of u and a plus 1 sine of u, so that's plus 3 sine of u. Okay, so let's rearrange that as 3 sine of u minus 4 sine cubed of u. And if we factor out a sine of u, we get 3 minus 4 sine squared of u. Check. It's very difficult when you start. I did this just like you for the first time, just trying to whittle it down to where we can get it to look something like this. There's only a few things you can do to start. So you just start, and maybe you have to erase and go back, but just do the best you can. All right, so let's look at 26. Now we have the sine of 4t. That's just crazy. We could attack the right side, but to tell you the truth, I'm not even sure what to do with the right side. I think on the left side, we should just do sine of 2t plus 2t and just break it down from there. All right, so again, the addition formula is the sine of the first, cosine of the second, plus sine of the second, cosine of the second. first, whatever, it doesn't matter. They're both the same. First and second are both 2t. Okay, so now, technically, this is 1, and 1 makes 2 sine of 2t cosine of 2t, which we have two double angle formulas here. Now, look in the answer here. We both have sines and cosines. So we don't want to remove all the cosines here. So let's use the sine of 2u down here at the bottom and change it all, okay? Because these are all 1t's. We need to get rid of this double 2 here, okay? So we're going to make this 2 times. The sine of 2t is 2 sine of t cosine of t. I'm going to get rid of the t for now since we got rid of the double. And then also the cosine of 2t. We get to choose between the 3 down here what we want to use. So I see, I think the middle one might be the best because we do need to get a sine squared out of this. And we still have a cosine at the beginning here. So this is going to be times, and it's a group, 1 minus 2 sine squared t. Huh. And look at that. This looks very close to what we need. We just need it to be a 4, which if we multiply through there, we get 4 sine of t cosine of t times 1 minus 2 sine squared of t. All right, and that's the answer. Check. 27. All right, again, cosine of 4 theta. Let's just go ahead and make it cosine of 2 theta and 2 theta. So the sum formula for cosine is cosine cosine minus sine sine. All right, now they're double angles. And now look at what we need here. We need no sines in here. So I look at the cosine of the double angle formulas down here at the bottom. And I want to I don't want to use one that has sine in it. So that means I'm going to use this third one here. So both of these two are 2 cosine squared of theta minus 1. So you have 2 of them. You still have the minus sine of 2 theta. This should be sine of 2 theta as well. So minus 2 sine of 2 theta, basically. Because we have 2 of them. I'm sorry, that's not right. It should be sine squared, but let me rewrite that. Sine of 2 theta, sine of 2 theta. Okay, so sine of 2 theta, again, we're stuck with a sine. So we have 2 of these. So that's going to be, it's minus the whole thing here, okay? This will be 2 sine of theta cosine of theta times 2 sine of theta cosine of theta. All right, or we say minus 4 sine squared of theta cosine squared of theta. That's the right side of that. So I see a bunch of 8s up at the top here. So we're going to have to do something to make these bigger. So I'm going to go ahead and distribute here. That gives me 4 cosine to the 4th theta, which that's what we need. We need to the 4th at some point. And then minus 2 cosine theta and a minus 2 cosine theta is a minus 4 cosine squared of theta and a plus 1. And it's minus 4 sine squared cosine squared of theta. Okay, so we got to get rid of the sine squared, which is 1 minus cosine squared. Okay? So we need to distribute here. We're going to distribute the 4 and the cosine squared of theta at the same time. So let's rewrite this. 4 cosine to the 4th minus 4 cosine squared plus 1. And if we distribute a 4 and a cosine squared, we get times 1, we get minus 4 cosine squared. Remember, this is a minus sign in between here. We're distributing it with the 4. And then times the negative cosine squared will give me a positive 4 cosine to the 4th theta. So let me show you what I was doing here in a second. 4 1 minus cosine squared times cosine squared. So basically I was just putting this over here, minus 4 cosine squared, and we're going to distribute it through here. So that's minus 4 cosine squared of theta and a plus 4 cosine to the 4th theta. So that's what I was doing right there. So I'm going to erase that. All right. Now, what do we have? Let's put like terms together. 4 cosine to the 4th and 4 cosine to the 4th is 8 cosine to the 4th theta. Hey, that looks good so far. A minus 4 cosine squared and a minus 4 cosine squared is minus 8 cosine squared. And there's a plus 1 left over. Check. I think 28 is getting to the point where it's the same type of thing. You're just doing more and more of it. And they can be done shortly, but I think you get the point. Let's go on to another type of problem. We have a sine to the 4th here on number 29. So we can change that, or we can try to work on this ugly beast to the right of it. I would probably change that to sine squared squared. And what do we have for sine squared? So our sine squared is right here. We can use that to get us going. Okay, so we have 1 minus cosine, cosine of 2, in this case t, I'm going to leave the t off, cosine of 2 over 2. We're going to square that. So really, what do we have? We have 1/2. We're going to put the 2 underneath both terms in the numerator. Cosine of 2t over 2. Now we're going to square this. So that means we have 2 of these. 1/2 minus cosine 2t over 2. I'm going to change this from t to an x. It'll just be easier. So if we distribute, we get 1/4. And this is going to be a minus the cosine over 4 cosine of 2t. Okay, and then we distribute this part. That's minus cosine 2t over 4x. I'm going to use x. And then the final one, plus cosine squared of 2x all over 4. All right, so this is crazy looking. You have these double angles now, cosine of 2x, which is fine. We want the double angle formula on some of the stuff. Notice what we have here. That is minus 2 cosine of 2x over 4, and the 4 and the 2 reduce to minus 1/2, or minus cosine of 2x, which is what our center part is. The issue is now, how do we get 1/8 out of the first and the last part? All right, so we're going to have to change the cosine squared of a double angle here. Okay, so the cosine squared of a double angle is going to change it to the cosine of twice whatever that angle is. So instead of 2x, it becomes 4x. So the cosine squared of u right here becomes cosine of 2u. So if the u is 2x, then it becomes 4x in the formula. All right, so we're going to rewrite that. So we have 1/4. We have finally our minus cosine of 2x over 2. And then the cosine squared of 2x, we'll use this as, this is plus 1 plus the cosine of 4x all over 2. And that's all over 4. Okay, now watch what happens. You multiply this by the reciprocal. That's where the 8 comes from. So 1/4 minus cosine of 2x over 2 plus 1 plus cosine of 4x over 8. And you say, well, what happened? How does this become 3/8? Well, notice what happens if we take this. We're going to make it 1/8 plus the cosine of 4x over 8. Now the 1/8 and the 1/4 get a common denominator, multiply by 2. So that's 2/8, and 1/8 gives me 3/8. And there we have the right side of the problem. Crazy stuff. All right, let me clean it up. We can do number 30. All right, so cleaning it up, I just moved it to the next slide. So let's add the formulas to the other slide too. All right, so the left side looks like a difference of squares, so we're going to do cosine squared minus sine squared times cosine squared plus sine squared. All right, so notice we have cosine squared minus sine squared down here at the bottom. That becomes cosine of 2x, which is what we want. So what is cosine squared plus sine squared? That's 1. So, ta-da, done. Okay, so secant of 2u. Now we're getting into the reciprocal identities, which can be kind of confusing at times. But again, I'm sure there are ways you can do some of these faster. Like that last problem was done really fast. I just caught on quickly to what it was. The other ones, I think I took a little longer than normal, but we got it done. You might be able to find a faster way on certain things. So the same thing with these. If you want to change it, let's change everything, in my opinion, change everything to sines and cosines and simplify before we move on. So the secant of 2 theta is the same thing as 1 over cosine. So the cosine of 2 theta would be the reciprocal of what we have here. The 2 secant squared on top and the secant squared would be then on the bottom. It's a reciprocal. Now we change these to the reciprocals. Secant squared is 1 over cosine squared. Okay, and get multiplied by cosine squared on the top and bottom here, and we get 2 cosine squared of theta minus 1 all over cosine squared of theta. And we're going to multiply by the reciprocal, and the cosine squareds cancel out. And we have 2 cosine squared of theta minus 1, which at the bottom here is cosine of 2 theta. Check. Right side is the same as the left side. Same type of thing on 32, except now we're dealing with tangent stuff. We could change them to sines and cosines if you want. Let's put them in tangent form because that's what we're probably going to be using. So cotangent is the same as 1 over tangent, or you take the tangent of 2u and you flip this upside down. So 2 cotangent of u over cotangent squared of u minus 1. And do the same thing we did in the last problem. That becomes 2 over the tangent of u and 1 over the tangent squared of u minus 1. So we need common denominator, tangent squared over tangent squared. So what do we have here? On the top we have 2 over tangent of u. We're going to multiply, well, let's do the bottom first here. We have 1 minus tangent squared all over tangent squared. So if we multiply by the reciprocal, tangent squared goes on top, 1 minus tangent squared on the bottom. 1 tangent here reduces with 1 there. So we have 2 tangent of u all over 1 minus tangent squared of u. And if you look down here at the bottom, that is exactly the tangent of 2u. Check. Pretty difficult stuff, guys. Just got to work through them a little bit at a time. So obviously we are not going to work with 1. I mean, we could do a bunch of different things with 1. You have a bunch of 1s down here at the bottom, but I think it's best if we just work through the left side. All right, so 2 tangent squared of 2u. So looking at the formulas, I think if we change this, we can use these formulas here at the bottom to change them to the 2t that we need. And also we have these sine squareds that could cancel out. So I'm just going to use the first one to start with, see how that works. So watch what happens. 2 sine squared of t, 2t, plus, now the cosine of 4t. Notice down here, if it's 2u, it becomes just 1u in the formula. So it's half as much. So the cosine of 4t is going to become cosine squared of 2t minus sine squared of 2t. All right, so now what do we have? We have a 2 sine squared of 2t minus a 1 sine squared of 2t. That's 1 sine squared of 2t plus cosine squared of 2t. Well, sine squared plus cosine squared is 1. Check. Okay, tangent theta plus cotangent of theta. Again, you could do a whole bunch of different things. I think we should start with the cosecant and turn it into the sine. So this is 2 times 1 over the sine of 2 theta, or 2 over sine of 2 theta. Okay, now what is the sine of 2 theta? And this becomes 2 over 2 sine of theta cosine of theta. The 2's reduce out, leaving 1 over the sine of theta cosine of theta. Okay, same thing as 1 over the sine of theta times 1 over the cosine of theta. Okay, so now I know that I need to get a tangent here somehow. 1 over the sine of theta. We'll put cosine of theta back up as secant of theta. Okay, so now we have secant over sine. If I multiply top and bottom by secant over secant, I get secant squared over sine times secant. Okay, secant squared is tangent squared plus 1 over sine times secant. But secant is the reciprocal of the cosine, so since it's in the denominator, the cosine, so we have tangent squared plus 1 times the cosine all over the sine. And what do we have here? Cosine over the sine is the cotangent. Okay, so now we have cotangent times the tangent squared plus cotangent. Okay, if we use sines and cosines, sine squared over cosine squared times cosine over sine. Look at what happens. The 1 cosine makes this a 1 cosine in the denominator. The 1 sine in the denominator makes it a 1 in the top. So what do we have? We have tangent plus cotangent. Check.